So we looked kind of at what a square root is, just for the complete taking the perfect square. But a square root of 49 is really just two numbers that equal the same thing multiplied together. To get that number, that's what the square root of 49 is. So 7 times 7 is 49. The square root of 49 is 7. Since 7 times 7 is 49. But I'm not going to stop there. What if I were to tell you that there's actually another answer that is the square root of 49? There's not just one, just a 7. What other number could I use? I'm just going to have you think about it for 5 seconds. You're about to chat with your partner. If you don't have a partner, look behind you. Maddie, talk to Porter. Lexi, talk to Andrew. And Sarah, team up with Team Maya. Tanner. Talk to your partner. Get ready. Go. What number could include with the 7 to make a 49? 7 times 7 is 49. What else times what else is 49? What times what is 49? Think about it. There's something else. There's something else. Okay. Raise your hand. Voice is off. What times what could be 49, Addison? Because you have two negatives making a positive. The answer to the square root of 49 is not just 7. It is also -7. You'll see this weird little symbol here where it says a plus minus square root. Whenever you take the square root of something, you are going to have to include a plus and a minus option. So the answer for this is 7 and -7. The square root of 25 would be 5 or -5. The square root of 12, ooh, do I want to get into that?
Here we go.
We're going to have a whole unit on this, you guys. But when I take the factor of 12, I get 4 times 3. This is the same thing as the square root of 4 times 3, or the square root of 2 times 2 times 3. If you have a square root that's not a perfect square, like 16, 25, 36, 49, I cannot take two numbers. The only thing you can do is try to play a matching game and get two numbers that are the same. That 2 times that 2 can be pulled out. The 3 is left over. We're going to pause on that. Put a little star. Put a little star next to E. D, the square root of 16 over the square root of 9 is the same thing as this. So this answer could be 4 over 3 or -4 over 3. Square root of 16 is 4, square root of 9 is 3. 4 over 3 is the same thing as square root of 16 over 9. Don't worry about C too much. So in summary, we write the square roots as plus and negative signs. Since 4 squared is 16 and -4 to the second is 16, they can both work. Stop and jot. Example 1.
Yeah,
what is different, or just what, about this quadratic? I'm going to set this up for you and make it look a little simpler, and then I want you to try to solve and jot down 1 or 2 sentences about what is kind of weird with this one. I'm going to subtract by 2 to make my very own 0. What I'm left with is something kind of weird. 4x squared minus 7 equals 0. Okay. It's this problem, you guys. So a similar problem. It's not going to change what you think about. What is weird about factoring 4x squared minus 5 equals 2, and then it becomes 4x squared minus 7? What's kind of weird about factoring that? Silent hand. Why is it weird? What makes it weird? Like, we've had one method of doing this thing, and so far this looks kind of strange. Go ahead. Yeah. Wyatt. Okay, there's an x on one side, but we've done something before where it was like 4x squared plus 9 equals 0. Like we've done that before, and we've made a perfect square. So we've done those types of problems. What makes this one weird? Jackson. Nothing that multiplies to 7. So we would call this, on your test previously, you wrote this. You wrote not factorable. So what's different about this is it's not factorable. You can't factor it. And that was the answer so far on the last test you took. You just put not factorable, I can't factor this, and moved on. From here on out, there's another method to solving quadratics. Factoring is the biggest method in Algebra 1. You will try to factor because it seems to be the most simplest for most students and it works for most problems, but it's not always going to work. For this problem, I want you to change the 2 to an 11 because I think it just got kind of weird. Erase it. It's not, that's not an algebraic move. I'm just doing it because I'm the king of algebra and J16. Wyatt, you're gonna deal with it. I'm the king of algebra, yeah. From there, okay. I have 4x squared minus 5 equals 11. Because I know that I cannot make this work, I'm going to do something called taking the square root. And my goal is to move everything to the right side until I have an x squared on the left. I'm going to move everything kind of like I'm solving an equation. 4x squared equals 16. Last step to get x squared by itself is to divide by 4. Yeah. This one is factorable now. Yeah, my example isn't perfect for this one, so yes, but just bear with me. When you have x squared equals 4, you notice something happens. This is a perfect square, but I don't have x equals something. I need to make it into x equals. I'm going to take the square root of the left side. The square root of x is just x. The square root of x squared is x, because x times x works. Then take a square root of the right side. But when you do this, because taking the square root of 4 gives a positive and negative sign option, you need to have it be plus or minus. What's the square root of 4 full class? 2. So your answer for this is plus or minus 2. If you want to put plus or minus as the options, you can list it like this, or you can list it separately. They're the same answer. Okay, next one. Hopefully this is a little bit better. I think it is. Yay. 2x squared minus 8. This one's better, Tony. It doesn't have an easy option. I'm looking at this thing and I could factor something out right away, but I'm not going to. When I use this option, you can take the square root and not have to factor it. Let's add 8 to both sides. That leaves 2x squared and a positive 8. Next step, I want to get x squared by itself, so I need to divide by 2. You get x squared equals 4 again. This one has the same answer. Can I stop here and put this as the answer, Mackenzie? Why not? We want the option to have x on one side, so I'm going to take the square root. Sarah, turn all the way, please. When I take the square root, what happens to the right side, Andrew? Oops. What happens to the right side when I take the square root of a number? There's two options now. Let's look up at what happened up here. When I took the square root, what did I add? A plus and a minus sign. So it's just the two options are plus and minus 2. Your turn, do 4 and 5 on your own. Let's make sure these work. Number 4 is going to look great. Number 4 works for this one. Number 5 looks kind of funky. I'll talk to you about what that looks like when we get to it. So for these, if you're taking the square root, I don't want to factor anything. I'm going to move everything to the right. That's 27. So you could, but I would move everything to the left side. I know. Yeah, go ahead. Number 5 looks tricky, guys. Just pause on that one. All right, Wyatt, give me the answer for number 4. We'll work backwards. It would not be just 3. It would be... Keep going.
He's a boss.
So what is the answer? Keep going.
I was gonna say that.
X squared equals 9. But then we have to find the square root, right?
Yep. And what would the answer be?
No.
No.
1.5.
No.
Okay, when I take the square root of 9, there are two options. 3 times 3 works, but there's another option. This would give you 2.5 out of 5 on a test. What's my other option? When you take the square root, you always have two options, plus and a minus. If you list just a plus 3 for this, your answer is wrong. You cannot have just a positive 3. It's either plus or it's minus. Yeah. Tanner.
In the plus minus thing, the negative stuff in the subtraction sign means like rather low. I think it's a little unnecessary. I think we should change the sign. Because it shouldn't be at the bottom.
All right, number 5. This one looks weird. 5x squared equals 11. When you get to this and you divide, you'll notice that something weird happens. You don't have a perfect square. You have a weird fraction. And if that's the case, the only thing you can do is take the square root of this and call it good. I can't take the square root of 11 or 5 and simplify it, so your answer is literally just that. It might look kind of funky and it might make you not want to circle it, but that is as simple as you can make this problem. 11 over 5 you could, but I'm not going to make you do that. Okay, you don't have to. Example 2. When you have x plus 5 squared in parentheses, this problem is a little easier than example 1 because I can, before subtracting anything, just take the square root of both sides. When you take the square root of x plus 5, that's really just x plus 5 times x plus 5. So taking the square root of it is going to eliminate it just to one of the binomials. X plus 5 is left over. The square root of 36 is plus or minus 6. From here, you have two options. You have x plus 5 equals 6, and you have x plus 5 equals negative 6. Set them up separately and get our different answers. Kingston, what would the left side turn into?
1.
Okay, x equals 1 is one option. What about the right side, Sarah?
Negative 11.
Negative 11 is your second answer. That's it. When I have a number attached to the outside, I cannot take the square root of this entire thing because the 3 is attached. Before I take the square root, let's divide by 3. X minus 5 is still squared. I divided by 3 on the left side, which cancel it on the left. 18 divided by 3 is 6. Okay, from here, what's my next step? Colby.
So you do the square root, and for x minus 5, it would be x minus 5.
Good.
And then for 6,
It would be nothing, right? I can't, there's not a perfect square of 6. So I'm going to leave this one in the square roots, but I'm going to make it a plus and a minus option. Okay, this is another one that starts to look kind of funky. Let's put x minus 5 equals positive root 6 up here. And then x minus 5 equals negative root 6. Since I cannot simplify the 6, the only simplified way I can write this is to move the 5. X is now by itself. And you get 5 plus root 6, or root 6 plus 5. That is as simple as I can make it. Over here, do the same thing to the negative root 6. 5 minus root 6, or negative root 6 plus 5. You could go ahead and plug that in and make yourself a decimal with the square root, but you do not need to. Leave it as a square root is fine. Try 7 and 8 on your own. Yay. You don't get rid of the square root, Jordan, you just leave the square root there. So notice what I did with this 6 is it just stayed as a root 6 because I couldn't find a perfect square for it. Nothing times, or some number times the same number can't be a 6. Give me the answer for number 7, Felix. What did you get for this one? Did you change that up? No? Okay, I'll go back to you. You're fine. We'll go back to you for the next one. What did we get for this? Jordan. Just give me the answer.
There's 4, there's x equals negative, there's x equals negative 10 plus or minus 6 squared, and x equals plus minus 6 squared minus 10.
And I'm gonna change your vocab. It's not 6 squared, but it's the root 6 or square root 6. So 6 squared would look like this. It is not that. So that is your option. It is plus root 6 or minus root 6. Make sure you have those there. For the second one, you should take the square root of both sides first. X minus 9 equals plus or minus 8. And it looks like x can be 17. Or x would be 1. Questions on 7 or 8? Yeah, Wyatt. Square root is the opposite of squaring. We haven't worked a lot with this. You got some, hopefully, you guys didn't your 7th grade year because you skipped it. My goodness, I'm horrible. You're going to